Yeah, let's do it. Cool. All right, hello everyone. My name is Kevin, and I'm here with Barbara. Together, we both like to welcome you all to our latest Novedge webinar series episode. This is your overview of MecSoft's newly released standalone CAD/CAM software, VisualCAD CAM 2014. This new version features 5 modules that are fully integrated into one software interface. While sold separately, the modules include VisualCAD, VisualMILL, VisualTURN, VisualNEST, and VisualART. In this webinar, we'll be showcasing each of the modules and demonstrating the new features and functionality. For those of you who don't know who our presenter is, Uday Honnalagere is a technical support manager for MecSoft Corporation. He started as an application engineer and has been with the company since 2005. He is responsible for providing technical support and training for end users. Uday holds a MS degree in industrial engineering from Arizona State University, majoring in CAD and CAM. He is also joined by International Sales Manager Scott Dixon, VP of Sales and Operations Uday Honnalagere, and together they'll be answering any questions you might have about VisualCAD CAM 2014. So today's presentation is about 40 minutes long, and afterwards we'll have a brief Q&A where Uday and the team will answer your questions live. So submit yours to us at any time in the chat window below. But before we get going with today's presentation, here's an overview of what we do at Novedge. All right. So the Novedge webinar series is brought to you by Novedge.com. As one of the largest online design software stores, we offer a huge assortment of software solutions that cater to virtually every designer's need. To pick up MecSoft's VisualCAD CAM 2014 standard, you are welcome to call and speak with our specialist, Bob Dare. You can reach him by his email address, bob@novedge.com. And Barbara, I think you have a few words you want to mention?
Yes, I'm here to let you know about the Novedge blog, where you can glimpse at who is changing the world of design one step at a time. You can meet the innovators, the makers, the architects, the VFX artists who work right on the edge of creativity and technology. Great interviews, great images, and great stories. Come visit us today at blog.novedge.com. And to catch up with the latest product promos and Novedge webinars, like us on Facebook, another source of endless information. Next week, TDM Solutions' own Pedro Loureiro will create up to 5 jewelry design samples from scratch using features unique to both Clay U and Rhino Gold 4.0. Furthermore, he'll showcase the all-new Rhino Emboss 1.0 beta for reliefs, engravings, and texturing. It's going to be 100% hands-on. So looking already forward to it. The webinars is always free and will last about 1 hour, including the Q&A session. To sign up, head on over to www.novedge.com/webinar/104. Last but not least, today's webinar is being recorded live. If you want to rewatch episode 103 in its entirety, as always, you can find it on our Novedge webinar series channel through Vimeo and YouTube. Okay, guys, are you ready to present this demo? I'm already excited.
Yes, we are.
Fantastic.
Cool. All right, so I'm going to switch over to Uday right about now. Audience, let us know if anything is going haywire, but I don't think it will be. All right, enjoy, have fun, submit questions.
Thank you. Thanks, Kevin. Thanks, Barbara. Hello, everybody. Good morning, good afternoon, or good evening to folks wherever you joined us from, and thanks for taking us the time to take a look at the VisualCAD CAM 2014 webinar today. VisualCAD CAM 2014 is our flagship standalone CAD CAM software solution that MecSoft offers, and VisualCAM 2014 is our latest version release, and we offer several different modules all integrated in one roof. So we have the milling module for those of you who are looking for 2 to 5 axis machining solutions. We have a 2-axis turning module. We have a nesting module for 2D shapes, and we also have an art module where you can convert artwork images into 3D reliefs. Now, for this presentation, I'll be presenting the milling and the art modules, and my colleague Scott Dixon would be presenting you with the turning and nesting module. First, I would like to show you some of the nice features that we have to offer in the VisualCAD 2014 modules. For those of you who are looking for CAD modeling in VisualCAD CAM, it's a great way to start. So you don't have to, if you're looking for just a simple and easy to use 2D CAD module, this is the best place to start. So I'm going to go ahead and start up by taking a simple model in here where we can take a look at some of the powerful tools for CAD modeling in here. So I have this part drawn up in VisualCAD by using arcs and circles and curves. And I'm going to show you some of the features that we have introduced in the 2014 release where we can do what is called an automatic or continuous command recall for repetition of commands. So I would like to go ahead and trim these arcs in here and extrude it to form a 3D model. So I'm going to use the trim feature by selecting the trim command from the modify tab, and I'm going to go through the process of trimming some of these curves. And as you'll notice here, since I have the continuous command recall selected, it automatically repeats the command until I cancel out or exit out of the command. So I'm trimming out these arcs in here, as you can take a look at it. And it's a very powerful trim feature that's available to you in VisualCAD 2014. And the VisualCAD 2014 is included with the VisualCAD CAM 2014 module. So I'm going to go ahead and exit out of the feature. There's a pretty nice part that's already designed. Let me go ahead and merge these curves. I'm going to use the merge feature and merge it. So basically it creates a closed curve right there. Now let's go ahead and turn this into a 3D model. So I'm going to go over to the isometric view. You can also see that VisualCAD gives you nice view rotations and orientations. And also the latest version release supports 3D connection devices. If you have a 3D mouse that you like to use with it, you're more than welcome to do that. So let's go ahead and turn this into a 3D model. I'm going to go under Surface and Meshes and use the Extrude feature and specify a height for it. So let's go ahead and extrude it to a 1-inch thick material. So there's a nice 3D model that we just created in VisualCAD CAM 2014. Now, there are several transformation tools also that's being offered in VisualCAD CAM 2014. One of the tools I would like to demonstrate here is the ability to do a graphical scale in here. So I'm going to go up to the transform menu and click on graphical scale, and I can actually specify graphically, pick the center, specify the first reference point and the second reference point to scale the part. So there's your graphical scale feature in VisualCAD CAM 2014. Now there are several other features I would like to demonstrate here, so I'm going to go ahead and pull in a second example where we'd like to take a look at how we can create NURBS curves in VisualCAD 2014. Now here's a part where I've actually created a couple of NURBS curves in here. You can go to the Curves tab and select the NURBS curve feature where you can specify the degree of the B-spline and create the NURBS curve. Now once you have these curves created, you can also modify or edit these curves in VisualCAD. So to do this, I'm going to go ahead and click on the Object Properties window and select on the Edit mode. Now this basically displays all the edit points that I can use to modify it. So I can actually go grab a point in here and modify the NURBS curve. So I'm going to slightly change the shape of the NURBS curve. Once you have it edited, you can exit out of the Edit mode in here. And if you want to take these curves and turn them into solid surface geometries, you're more than welcome to do that. So I'm going to go up to the isometric view in here in VisualCAD. You can also work in multiple viewports, as you can see here. And let's go create a surface. I'm going to go grab surface of revolution. And for the curve to revolve, I'll select the NURBS curve in here. And for the revolution, I'm just going to use these reference lines I've drawn. And that'll allow me to create a surface of revolution where I can also specify the angle, the start and end angle values. And there's your revolution, surface of revolution. So VisualCAD offers an extensive set of CAD modeling tools which can be used for your designing as well as for machining purposes. I can repeat the same surface of revolution command on the NURBS curve over here on the right side. Just grab the reference points, specify the start angle and the end angle for the revolution. So there's your surface revolution. You can view it from different view orientations, the top view, the front view, isometric view. There it is. Now let's take a look at some of the other functionalities that we have to offer in VisualCAD 2014. One of the features I would like to demonstrate is the ability to do rectangular scaling. This could be a very helpful tool when you want to try to fit some artwork or geometries into a predefined stock shape. So I can go ahead and pre-select the geometries, go up to Transform, and use rectangular scale. This automatically displays the bounding rectangle of the geometry, and you can use the snaps to go ahead and snap it out to the extent of the stock piece. And there's your rectangular scale. So there are a lot of powerful tools that are packed with VisualCAD CAM 2014. We also have a new feature called Manipulator, where you can graphically select these objects and move them. You can transform them by specifying either a value, you can enter a distance in here, or you can even specify by dragging it by using one of the coordinate arrows that you can see on the screen. Now, this kind of gives you a summary and overview of all the different CAD tools. There are a lot more available to you. If you have any questions, feel free to give us a call, or if you'd like to schedule a one-on-one demo to take a look at the features of VisualCAD CAM, feel free to do so. We would now like to go ahead and introduce you to the milling module in VisualCAD CAM. So to load the milling module, we'll click on VisualCAM and select Mill. Now this loads the machining operations and the machining objects browser for the mill module. I'm going to go ahead and load a part in here where we can program some 2- and 3-axis toolpaths, and we would like to take a look at, give you, all the feature sets that are available in the VisualCAM's milling module. The mill module is available in 4 different configurations. We have Standard, Expert, Pro, and Premium. The Standard offers 2- and 3-axis machining methods. The Expert also includes the 4-axis features. The Pro includes advanced 3D milling, remachining, pencil tracing, index 5-axis machining, which is also known as 3+2 machining. The Premium configuration also includes simultaneous or continuous 5-axis machining. Now, to program this part in VisualCAD CAM 2014, the first step I'm going to go over is go to the Program tab under the Machining Operations browser, and you'll notice that there are 3 different groups under the Program tab. You have the Machine Setup, the Stock, and the Machining Operations. The workflow is going from left to right as you work through each of these groups. Now, the first step is to define the machining process. We can select the machine type as number of axes is 3-axis, 4 or 5-axis. Now for this particular application, I'm going to choose 3-axis, where you can program both 2- and 3-axis toolpaths. In the next step, I can select the post processor. VisualCAD CAM includes a wide range of post processors. It includes over 220 plus different posts, which covers a wide range of CNC machines that are out there. And these post processors can also be customized and edited to suit your needs. So if you need to make any changes or tweaks, you can use the post generator to make those required changes on it. Once you have the part loaded and you establish the orientation, in the next step we can go define the stock. There are different ways you can define stock. For this particular example, we'll go define a box stock in here. We have the length, width, and the height defined. For the stock, we're going to go with 10 by 6.5 by 2 inches. In the next step, I would like to go ahead and align it. So I can use the Align Stock feature to have it aligned. You can have it flush to the bottom of the part and have it centered in X and Y. So once you have the part and the stock aligned, you can select the material that you'd like to use for this process. I'm going to use aluminum 6061 and also apply the texture on it. This basically displays a nice texture of aluminum on the stock line. We would now like to go ahead and establish the origin and program the toolpath. So we can do that by going to Align and using Set World Coordinate System. We'll choose Set to Stock Box. And I'm going to pick the 0 face as the highest Z, which is the top face of the block. And I'll pick the southwest corner, which would be the lower left corner. If you'd like to pick a point, you can use the pick option and snap to a point on the geometry as well. Now, we have a wide range of toolpath methods, starting with 2-axis, 3-axis methods. Now, for this application, I'm going to bring in a knowledge base of operations, which I had pre-programmed and saved from one of the files. So I can go up to knowledge base and use load knowledge base, or I can do it from the machining objects browser, where I can choose only certain operations to be loaded from a knowledge base for programming this part. So the first step I'm going to use is a roughing operation. I want to rough it down or face it down to the top face of the part, and I'm going to specify a tool. In this case, I'm going to be using a 1-inch end mill. Plug in my feet and speeds. Now the tools can also be edited, customized, and you can also define your feet and speeds for the tool based on the material that you're working with, and VisualCAD CAM includes a feet and speeds calculator that's built into the product. You can define the clearance height. This can be set to automatic, where the system automatically figures out the safe clearance height for all the transfer motions and non-cutting motions. And here we can define all the cutting parameters for the roughing process. And selecting Generate creates the toolpath. VisualMILL automatically analyzes the part geometry, takes into account the stock geometry that's being defined, and automatically computes the toolpath. Now here's your roughing toolpath. Let's look at the toolpath visibility. You can also view the toolpath as you're stepping in levels. Now let's go run a verification in here. So you can switch over to the Simulate tab, click on the operation, and selecting Play shows the material removal simulation. You can also toggle the display of your toolpath as well as the texture visibility during simulation. And if you'd like to speed up the simulation, you can click on Pause and select Simulate to End. Now there is the process where we faced it down to the top face of the part. In the next step, I would like to go ahead and machine these pockets in here. So I'm going to make use of the two-axis pocketing operation. I would like to go ahead and select the features for pocketing. I can either select a surface edge from the face of the part, or I can even pick a closed curve that represents the boundary or the area that I'd like to pocket. Now to determine the depth, I can pick the depth of the 3D model by just snapping to the 2 points in the model. I can pick the top face and also a bottom face near the edge of the part. So there's the total depth, and selecting Generate creates our pocketing toolpath. Now with the 2014 release, we've made several enhancements to the pocketing operation. We've introduced a feature called Clean Corners, which actually results in a high-speed cleanup loops. So this feature allows you to run the toolpath at higher feed rates, which basically prolongs your tool life, reduces your costs, and results in savings to you. Let's go ahead and run the simulation. Now this is one of the enhancements and new features that's available in the 2014 version of VisualCAD CAM. The next step, I would like to go ahead and pocket the 2 holes. I'm going to make a copy of this operation by selecting the operation, right-click, copy, and paste. And now let's go ahead and modify the machining features. I'm going to go pick the 2 holes by selecting the curves from the edge of the part. And all I'm going to do is modify the total cut depth in here by snapping to the top edge and the bottom edge of the feature. So I can go back in here and reselect the depths by just picking 2 points on the model. And selecting Generate creates a toolpath. Now you'll notice that the toolpath pockets the hole on the left first, and then does the hole on the right, and you'll notice that the tool transfers over all the way up to the clearance plane. You could change your clearance definition in here by using a skim clearance for the cut transfer and specify skim height. So rather than moving the tool all the way up to the clearance plane when it transfers over, you can have it just skim over the surface by a certain height. So these are some of the very nice features that are available to you in VisualCAD CAM 2014. I would now like to show you one of the brand new toolpath methods that's been introduced in the 2014 version. This is known as the high-speed pocketing method. Now this toolpath method results in constant tool engagement. The toolpath is formed with tangential arcs, so the advantage is you will be able to run it at much higher feed rates, resulting in savings in cost and prolongs your tool life. Now we can select either surface edges or curves, or we can even select flat areas. In this case, I'm going to pick the floor of the pocket as my machining feature. I'm going to pick 2 of these pockets in here and specify my parameters for the high-speed pocketing and select Generate. Now there's your high-speed pocketing toolpath. It starts with a spiral pattern and then creates constant tangential arcs, so basically gives you constant cutter engagement in here. Now this is one of the new features which is available across all configurations of VisualMILL 2014, Standard, Expert, Pro, and Premium. Now I'm going to use a pocket operation to program the remaining pockets in here. So I'm going to use the 2-axis pocketing routine. And rather than having to go and select each of these features individually, I've defined what is called a predefined machining region. I'm going to grab the region set number 1, basically which has regions for all of the remaining pockets selected, and selecting Generate to program these toolpaths. Now we can define these predefined regions under the Regions tab. To create a predefined region, you can either use a curve or a surface edge. If I would like to add a new region set, I can click on Create a Machining Region Set and choose Create a Flat Area Region. I can just pick this face and automatically establish this region. Now to select a predefined region in any machining operation, you can just go over to the machining operation and use Select Predefined. And if you like to select a set of these regions, you can just grab the region set and then select OK and generate the toolpath. Now there is your pocketing operation for the features on this model. Now let's go ahead and quickly program a couple of drilling operations to drill the holes on the top, and then we'll do the chamfer and the profile. So I already have a knowledge base of operations, so I'm going to grab the deep drill operation in here, and I'm going to go select the features. You can also apply a filter for the holes to select. I'm going to say I want to select all the holes that are between a diameter of 0.4 and 1 inches. You select holes on a flat area, and just pick the top face of the part, and you'll notice that it automatically selects all of these hole features. I have a tool defined for the drill, a 1/2 inch drill bit, and I'm going to use a deep drill operation and select generate. So deep drill is same as your peg drilling cycle. Now there is your drilling operation. Now let's go ahead and do the chamfers. I'm going to use the chamfering routine, specify the machining features. I'm going to go grab the chamfers on the bottom edge of this feature in here. I'm selecting the two face edges on the part. And there it is. Selecting generate creates our chamfer toolpath. You can go back and rerun the simulation for it. Now let's go ahead and program the profile to cut out the outer shape of the part. Now in this particular case, I'm going to use a predefined region, which is the curve region number 10. I'll select that and click generate. Now there's your profile toolpath that follows the contour of the geometry. Now if you'd like to choose a start point where you'd like the cutter to enter and leave the material, the profiling operation uses the start point of the curve geometry. So I can go over to the regions tab and select the curve and use the feature called select the start point and just go grab a start point on the part. And there's the new start point. And as you notice here, when you select the start point, it automatically flags the machining operation as dirty, indicating that you made some changes to the machining feature. I would like to go back and regenerate it. Right click and regenerate, recomputes the toolpath. And there's your simulation. So this is how easily you can program parts with different features using a combination of 2- and 3-axis machining operation methods. Now once I have these toolpaths programmed, I could take a look at the estimated machining time by selecting information. So it gives you a time for each operation that's involved in programming this part, and also a total subtotal of the total machining time. I would now like to go ahead and post-process these out of the machine. So I'm going to right-click and do a post, and selecting this automatically posts all of these operations, and you'll be prompted to specify your posted output file name and the destination folder, and selecting post displays your posted code. Now we can transfer this program out to your CNC machine controller. One of the very nice features that's VisualCAD offers is the ability to document all of the setup process. We have a feature called shop documentation, which you can use to generate a nice little setup information sheet, which gives you a list of all the operations that's being programmed, gives you the tools that are being used, and also gives you the machining time estimates of it. So right-click and shop documentation gives you the setup information sheet for the job that you're trying to program. Now these are just some of the 2D or 2.5D toolpaths that we've programmed in VisualCAD. There's several different methods. I'll also go through a quick example of a 3-axis toolpath, and before I hand this over to my colleague Scott Dixon, who will be giving you a presentation of the turning module. Now to archive all of these toolpaths that you program, you can go up to knowledge base and use save knowledge base, so these operations can be saved, which can then be used on other part files to be programmed. Now let's take a look at a 3-axis example in here. So I'm going to go ahead and load this model, which involves a lot of sculpted surfaces, and we'll see how best we can program it here. So we have a roughing process, a 3-axis roughing, so you can access this from the 3-axis methods. This is the primary process of roughing it in levels. You can specify your tolerances, your stock, your cutting parameters, and generate the toolpath. And then we'll do a facing operation to mill to the face of the part. And we have a roughing operation that roughs these pockets in here. So you can specify containment areas to contain or limit toolpaths to specific areas on the model. I also have a parallel finishing toolpath in the 3D. This can be used as a pre-finish or a semi-finish operation. We also offer advanced 3D toolpath methods like 3D offset pocketing, which results in constant 3D step over, also known as constant scallop machining. And we have remachining and pencil tracing methods as well. Now let's go ahead and run a quick simulation of these toolpaths. I'm going to switch the simulation model over to the voxel simulation and quickly give you a simulation of these operations in here. So I can select these operations, and selecting play shows the material removal simulation. You can also pause it and hit simulate to end. So there's your roughing simulation, and we're now finishing the face by doing a 2D facing operation. So you can mix and match 2- and 3-axis operations. I'm going to run a roughing toolpath for the pockets. And let's run the pre-finishing operation, also known as parallel finishing. So there's a simulation of the parallel finishing toolpath. I'm going to pause it and run through the end. Look at that. Let's run the 3D pocketing simulation. That basically finishes it. Now, to clean up these scallops, I'm going to run the pencil tracing operation on this part here. So basically goes around the part, identifies all those bitangencies on the model, and creates a nice toolpath to clean it up. Now, there are several powerful features that are being offered in VisualCAD CAM. One of the features I would like to show is an option where you can instance toolpaths. Now, if you have features that are similar that you'd like to instance or reprogram it, you could generate toolpaths on one of these features and use what is called an XY instance operation, where you can actually specify the spacing so it creates multiple copies, like a linear pattern of these toolpaths. Now, these are also available to you in the Pro and Premium configurations of VisualCAD CAM 2014. One of the very powerful features that we've introduced in the 2014 version is to take advantage of multi-core processing on your computer. So we have a feature called multi-threading. So I can actually select multiple operations in here, and as I regenerate these operations, they are generated in multiple threads, which means they're automatically placed on different cores on your processor. If you have a multi-core processor, you can take advantage of those for generation of toolpaths. Now, without any further delays, I would like to go ahead and invite my colleague Scott, who's going to give you a presentation of the turning and the nesting module. Over to you, Scott.
Uday, thank you very much. Very nice job on the demonstration as usual. We're very excited about bringing the turning module into our product and integrating it into the CAD host system. To get to turning, it's very easy. As Uday has showed, you just go up to the menu bar, select Visual Cam, and then select the turning from the pull down, and what will happen is the browser will appear on the left side of your screen, and it presents an environment for turning, including part, stock, and the machine definition will be turning oriented or machine or lathe oriented. So it's nicely integrated and very easy. In this demonstration today, we've decided that we could model a part here for you in VisualCAD, but we're going to do something different and bring in an IGES model that has been created from another system, which is common among many of our customers. So Uday is going to bring that model in. And one of the first things that we want to do once we've got that geometry into on our screen is we're going to go over and define that geometry as the part geometry for the system to understand. By bringing up this panel, we have two choices. One is to select geometry on the left side, or on the right to select some curves that may be a predefined cross-section. Since we have surfaces, let's use the left side, have Uday select all of those surfaces, and that will become the part definition for the turning module, and you see in the list on the left there that those surfaces have been selected. Okay, now the next thing then to do is to define the stock. The system will automatically, first of all, there's a number of different forms of stock, but if you choose the cylinder stock, the system will automatically build a minimum cylinder around the geometry that exists. And what we're going to do on this one is increase the diameter just a little bit, so we have some cleanup on the diameter of the part. And it shows there on the screen. One other thing that you can do once you've got the part and the stock defined is go to the adjust or the align capability, and there we can adjust the stock, either matching the front or the nose of the part or matching the back side, however you want, or put it in the middle. And right now we're going to match the front side of the part in our demonstration here, so we'll accept that as it is. Uday has rotated this into the other view. You'll see we have a nice view defined, predefined, which is a secondary ISO view. And it's very good for cutting in the first quadrant. You can see things very nice, and I think through the demo we'll go to that view every once in a while and show you that. All right, with the part and the stock defined and the part material has been aligned, let us bring in the operations. Now let me explain a little what we have done. Let's say yesterday we cut a part just like this and defined all the operations, and then we saved those. What Uday has done now is he's gone back to that knowledge base where those operations were saved and brought them into this part. by themselves, they represent the machining process for, let's say, a similar part or this part. What we'd like to do now is modify the work 0 that came in with that retrieval and make sure we have got the program 0 where we want it. And you will see it on the right end of the part. Here with this panel, you can modify that and place it wherever you want it, but it represents your 0 position for your program. So we're going to put it at the right side or the nose of the part. All right, very good. Now, first of all, let's just go in and generate one of the operations, which is the turning the rough OD operation. And Uday has brought that up in edit mode. We're going to go in and he's showing the tool definition and a variety of the tools that can be used for roughing on the OD. This includes the parameters for the parametric definition of the insert, as well as feeds and speeds, the offset register, the coolant, a number of other things that can be defined within the tool definition. And we're using here a 55-degree diamond. All right, the next thing let's do is look at just a few of the other parameters. One thing that we would like to do, which I think we should do right now, Uday, is you'll notice that on the OD of this part, we've got a large groove, and we would prefer that the 55-degree tool not go down into that groove. So what we're going to define is an avoidance line, and we're going to put a line across the top of the groove and prevent the roughing operation from taking the tool down inside that groove. All right, and that'll be added automatically as part of the boundary. All right, I think we're good on that. So we've got the other parameters set. We've generated that operation. Why don't we show briefly just a simulation of this? So go to the simulation panel. There's that view. Let's go to the simulation panel and notice that we have the ability to modify the simulation. We've taken the stock here. We have what's called a 3/4 view, which takes a pie section out of the stock so you can see inside. This is good especially for ID work, inside diameter work. And you can also, as Uday is pointing out here, the full size stock, even half or a quarter. But the 3/4 is by far more valuable for lathe work. All right, let's generate or simulate that one. I'm sorry, let's simulate that. And you can see, as you'd expect, the material being removed on the OD. And this is just the roughing, and you'll notice that, again, it did not enter down into the groove. All right, Uday, then let's go to the second operation, the finishing operation, and let's just go in and put on that same avoidance line for this one so that the finishing pass does not also descend down into the groove. By the way, the system does recognize the heel angle. It will not violate the part even if you did not do the avoidance geometry here as we're showing. Okay, that looks good. Let's generate that, shall we? Uday, can you generate that operation?
Yes, just give me one moment, Scott.
All right.
Thank you.
I was going to say the screen is frozen here. While he's doing that, just let me tell you a little bit more about some of the operations and the parameters here. Of course, you can, on the finish pass, you can select a range of start and end along the outside profile of the part. That is definable for you. All right, we're back. So there's the finishing operation. You'll notice at the very top there, where that small flange is, that the 55-degree diamond tool did not descend right behind the flange, but it actually projected itself out so as not to violate the flange or gouge the part. Very good. Okay, now let's do some ID work. Well, let's do the grooving first. We have a grooving operation. Why don't we just generate and simulate that with a straight tool, using a regular grooving tool. Take out that groove. Very good. And then let's go to do some ID work. The first thing we want to do is drill out the center line. And going into the other view shows that a little bit better with the simulation. The drilling operation, and then this one shows a straight shot drill right through. Could be a super drill, taking out the center there. The second operation again is just roughing, but we're specifying a different tool, an ID boring bar, in which we're going to rough out the excess material from the drill hole to within a stock value of the inside diameter. So we'll generate that. Uday, I think we're fine there.
Okay. Can you just give me one moment, Scott?
Okay. You have the ability, while he's doing this, you have the ability, all the same operation parameters for ID roughing. In fact, it's the same operation. You just specify a different tool, such as boring bar, that has an appropriate orientation for the insert, as you'd expect. And also specify that it is ID work, and the system will be able to rough out any region within the inside of the part. One change that I might offer to you, some of you who may be experienced with the old VisualTURN 1.0, we now can define geometry that has a hole in it and handle that much better than VisualTURN 1.0. All right, the last operation then was the ID finishing pass, and there we have our operations all done. Why don't we go back then and take a look, do a simulation of the whole thing all at once, if you would. Go to the setup, and we'll just watch it all the way through. And when we're done with that, we're going to let it go into post-processing. And we're going to run this against a FANUC controller for turning. We have approximately 40 post-processors, 4 lathes already in the system. And here's the panel for post-processing. And there's the list of the current operations, or current post-processors that we have. So let's post this entire job and just take a look at the listing of the operations again for that machine. And this file, of course, will be saved. Let's do one last thing then. Let's do the shop documentation to kind of match what you did in milling to show that this is capable. And the system will go through each one of the operations, capture pictures, compile a list of the tools, and then format that nicely in an output page or pages for your shop documentation. And there you have it. Now, one last thing that we don't necessarily need to do but can do, and that is that once you've finished any job like this and you're satisfied it, if you have other parts that are similar and you'd like to save all this CAM data, the operations, the setup, the tools, you can go through and save those to the knowledge base. They will be saved by a given name, the default name, and you can change that if it's general for you. You specify where to save it, and that'll be then available for you later to be used on other jobs and make your programming very fast, just as we demonstrated here. Anything else, Uday, that I missed that you'd like to add?
I think we just did fine. Great job, Scott.
All right, let's move on to nesting then, shall we?
Sure.
All right, let me just, while Uday is getting that nesting part together, let me just say a little bit about nesting. We do nest 2D shapes, and these are geometric nesting is what it's classified as. We have 2 distinct capabilities within nesting, and here's the part that we're going to demonstrate. just before we get into the nesting module itself, briefly let me just say you can recognize here a very large shape which represents the stock material that we're going to nest the parts onto, and we've made it irregular shape to indicate that we can handle remnants, basically, or of course rectangular parts. On the right side we have staged the parts that we are going to nest. So to get to nesting, let's just go up to, again, the VisualCAM pull down. We will select Nest, and again on the left side a browser will come up. The very first choice that we have here is either true shape or rectangular. Just briefly, we won't demonstrate rectangular. It is much the same with limited parameters or capabilities, but it handles only rectangular stock, and it nests a rectangular minimum box around each one of the parts. It's very good for the furniture industry, who basically has rectangular parts such as panel, cabinetry, and so forth. Okay, we're going to demonstrate true shape nesting. So the first thing that it's going to ask us to do is select the sheets. And so I'll have Uday go out and select that one large shape, and right mouse button accepts that, and then I'm going to have him set the count to 3, as if we have 3 of these sheets. And you'll notice that on that same panel, real quickly, you can specify where you want the nesting to start, any one of the 4 corners, the first direction that the nesting should be favored, and then of course we support grain direction, which has to be set both in the sheet material as well as in the parts that you want to match the grain direction. We won't take the time to demonstrate those, but you have a choice of X and Y. Next, let's select the parts, and I'm going to have Uday select the outside periphery of each one of these parts first, and the reason I have him do that is because it allows these shapes to be at the top of the list in the dialog, and that makes it easier to find those shapes, so we can put the count in there. Once he's select the outside, he can window select all of the inside shapes, and they will be added then to the list. Now Uday is going to enter the number of parts for each one of those, and while he's doing that, I just want to explain a couple other things. The system is smart enough to know that each cutout or hole, it knows within which of the outside shapes that cutout or hole is associated with. So whenever you specify multiple parts here, you only have to specify the count on the periphery shape, and the holes are automatically carried along for however many parts are nested, and that makes it very easy. Okay, again here, one of the parameters you notice is a fixed orientation and a grain direction. Let's fill out some of the other parameters down below. We're going to leave this orientation increment to be 90 degrees, but that as an orientation allows the system to turn the parts for a better fit. We will mirror the parts, and in the sake of time, Uday, maybe what we should do right now is let's allow the parts to be inside as well. This will nest smaller parts within the cutouts of larger parts. All right, let's choose the nesting parameters. Here, this is a metric part, so we want 3 millimeters between each of the adjacent parts and 6 millimeters between the parts and the outside edge of the material. By the way, notice that there is a help button on every one of these panels, which can take you to the help function to explain what these parameters are. Let's execute this nest. We've got the parameters all specified, and in just a moment the system will nest these parts and do the best job it can. And let's preview that. And on the preview panel, you'll notice that there are 2 entries in the list, which means it utilized 2 of the sheets of the 3 we specified. Did not send any of the parts into the third one. Also shows a percentage of utilization of the material. And I want you to understand that if this is not satisfactory at this point, you can go back up in the dialog, change parameters, regenerate the nest, take a look at it again, and refine it until the point that you're satisfied, at which time, and we will do this now, we will commit the nest, and each one of the sheets will be entered onto a new layer with a name that is identifiable with a new color, and you will see that this geometry then has been saved on those layers, and you can use this geometry then for any of your downstream applications such as milling, torch, laser, whatever you would like to use the nest for. Okay, briefly, that is nesting, and I'm going to turn the time back over to Uday and explain the ART module. Uday, it's all yours.
Thank you, Scott. Folks, I'm going to go ahead and give you a quick overview of the ART module in VisualCAD CAM 2014. So to load the ART module, I just select VisualCAM and choose ART. And as you notice here, the browser automatically switches over from the nesting to the ART or whatever browser session you're currently in. So I'm going to go ahead and load in an example in here just to kind of give you an overview of what you can accomplish with the ART module. So I'll go ahead and pull in this part here, where we can show you some of the pretty nice features. The ART module has 2 main tabs. We have the relief operations and then the raster to vector operations. Now, in the raster to vector operations, you can load image files and you can convert these into basically curves. For example, if you grab these text in here, I can convert these into the image from this into a curve geometry, which can either be used for engraving or you can create some reliefs using puff and swept volume. Now, in this particular example, I already have some curves created. This could be used using raster to vector, or it could have been done from your vector artworks. Now, the first step I'm going to do is define a project. In this specific step, I can specify the length and the width of the project. So I'm going to use a project that's going to be 4 inches by 10 inches, and I can also specify a resolution for it. Now, selecting Generate defines my project workspace where I can create some reliefs on it. In the next step, I would like to use some of these curves to create relief operations on them. So we have 3D relief, where you can generate relief from an image file. You can do puff and swept volumes by selecting curves that are being either drawn in VisualCAD or it could be imported into VisualCAD from a different system. So I'm going to use a feature called sweep operation. I'm going to choose the Boolean type as addition. I can do subtract, unite, high, low, or intersection high and low. I can pick from one of these cross sections and also select a curve for the relief. So I'm going to pick this curve that kind of looks like an ellipse as the border curve, specify a height for it, and click on Generate, and that basically creates a relief for us right there. Now, once I have the sweep operation done, I would like to use the curves, the artwork, to generate some puff operations. I can use the puff operations from the 3D relief operations tab, specify a cross section for the puff. You can also change these cross sections in here. You can specify the relief curves, so pick the border curves, and also you can pick the detail curves, which are the curves on the inside, and selecting Generate will create a puff operation. So it kind of creates a 3D relief of the artwork that you created. Now finally, I would like to go ahead and apply some textures in here. Now as I build this project, I can click on the project setup to kind of take a look at the result, what I generated using the operations in here. I would like to now go ahead and apply a relief in here. I can pick a texture for it, specify the texture file. I can grab a bitmap, JPEG, or an image file, select the operation type, and selecting Generate automatically creates a relief operation. Now when I click on Project, this shows the combined relief here, as you can take a look at it. Now this artwork is now ready for your downstream application. You can use these for milling applications, or you can save it out as an STL. If you like to send it out to a printing application, you can do that. So I'm going to quickly hit on Export Meshes as CAD. So basically this will convert this to a data which will be a polygon mesh, which can then be used in your milling application. If you like to use VisualMILL to generate toolpaths in here, I have it exported. I can quickly switch over to the milling browser and generate some toolpaths on it. Now the ART module also offers a variety of nice features. You can save these operations, what you create, into a library. So you can do what's called a shape library here. So you can do a right-click and say, save these shapes to a library. So when you're working on a project that's similar to these, you can automatically have the system load these projects for you. Now to give you an example here, I'm going to click on a new project, and I'll go ahead and define a workspace. I'll just create a workspace that's going to be 5 inches by 5 inches and select Generate. And I would like to load one of the shapes I have on my project. So I'm going to click on, go to my shape library, and select a shape I would like to load. So I'm going to go grab this dragon from my shape library. I'll just do a drag and drop, and I'm going to add this to the project. So you'll now notice that the project already has a shape geometry being loaded from a shape library. So this is how quickly you can define different shapes. Similar to your parts library, you can create a library of shapes for your relief work, export it to CAD, and it should be ready for machining. Folks, this kind of gives you an overview of all the different modules that we offer in VisualCAD CAM 2014. If you do have any questions, feel free to contact us. Let us know. We'll be more than happy to help you. Kevin, I would like to thank you for giving us an opportunity to present this VisualCAD CAM 2014, and over to you, Kevin.
Awesome, cool. So, Uday, I think we have some time, maybe 5 minutes to answer some questions. I have some I assigned to Scott and you and Anita as well. But let's see. I have a question from Ray. Ray wants to know, does this seminar also apply to RhinoCam, and in what ways? Because a lot of it is a duplication of Rhino features. What do you think?
That's a great question. Yes, we do have the milling module, the ART module, the turning module, and the nesting module available in RhinoCam as well. So if you're running Rhinoceros 5, you'll be able to run RhinoCam 2014, which will offer these modules.
Cool. And let's see. Does this software work on? Does this software work on desktop computers or just in laptops? I think it's both platforms are very capable of running VisualCAD CAM.
You're right. VisualCAD CAM is available in both 32 and 64-bit platforms, so you can either run it on desktops, workstations, laptop computers.
And Rob wants to know, he has a question on turning. Then you did the groving. Can you make it do every other and not all after this other as you did now? I might have to assign this to Scott.
Yeah, I'm not sure the interpretation. If it's every other in grooving, it's something that I've known to be called castling, if that's what my understanding is, and we do not do that that kind of cutting.
Cool. And another question, how do you know which number is... Hello?
Just lost you, Kevin.
Kevin, I can hear you, but...
Okay. Yeah, so I have a question about how do you know which number is which part? How do you delineate the different parts?
Is this for milling or turning?
I think this was, it might have been turning. Yes, it was definitely turning.
Okay, you mean how do you number the tools, or how do you call out different tools and offsets? I'm not fully clear on the question. Maybe if you could please elaborate on it.
Okay. Well, moving on so Ray gets back to us. Is there a tutorial guide for 2014? Oh, no, Ray, okay, yeah. Okay, let's answer Stephen's question about tutorial guides first.
Yes, we do have quick start tutorial guides. You can just access them by going to the help button from the VisualCAM 2014 or from the RhinoCam 2014. Click on help in the VisualCAM menu bar, and you have access to the quick start guides for milling, turning, art, and all the help files are built into the installer. So when you install the product, you'll have access to all of these files.
All right, and to get back to Ray's question, it was about the placement of parts.
Okay, in turning, or is it nesting placement of parts, or is it in turning?
Must be nesting, Uday.
Scott, would you want to answer that?
One of the things we didn't show is once you have selected the outside boundaries of each one of the parts as it's staged, you can, in the list that is created, you can click on, I think Uday did that, you can click on the name and it will highlight which part it is on the screen. That's how we relate the name in the list to the geometry on the screen. I hope that answers this question.
To us, so it was about nesting. Okay, so let's see. Lewis wants to know: does the milling option let you let your machine several parts at once?
Yes, you can. You can machine multiple parts at once. You can, create like multiple work offsets, or you can bring in, multiple different parts. You can import geometries and then program each part. You do it. You should be able to do multiple parts. However, there's only going to be one stock that you're going to be defining, but however, you can define machining regions or areas and define work zeros for each part that you're trying to program.
Cool. Okay, so John wants to know: does VisualCAD have a G-code sender to CNC?
Is he looking for a DNC solution? If that's the case, yes, we do partner with Spectrum Technologies, which offers a DNC solution. And you can find more information on that by going to our website, MecSoft.com, and click under, company and go to partners. And under CNC partners, you'll be able to find that information on our website right there.
Awesome. And I think this is one this is going to be our last question for the Q&A. Eric wants to know: is this a standalone program for CAD/CAM that works outside of SolidWorks, or can it work with SolidWorks?
That's a great question. VisualCAD CAM 2014 is a standalone application. We also do have VisualCAM fully integrated into SolidWorks, so you can run. If you'd like to know more about the SolidWorks plugin, you can visit our website, and it also runs in SolidWorks. But this demo, what we presented today, was a standalone CAD/CAM application.
Cool. Okay, so that pretty much sums up our Q&A. Uday, if you don't mind, I'm going to take over presenter responsibilities.
Absolutely, that's fine.
Cool. Awesome. Let's see, where am I? Here we are. All right, on behalf of everyone on Novedge and MecSoft, I want to thank everybody for joining and attending and submitting your questions for today's VisualCAD CAM 2014 demo. If you guys are interested in picking up the latest version, picking up standard, we also have other versions as well. Head on over to Novedge.com. We are an online design software store. We offer a huge assortment of solutions that cater to every designer's need. So whether it's CNC, CAD, CAM, whatever, we have it. We have VisualCAD CAM 2014 available in the U.S. and Canada. It's free shipping and zero sales tax. But if you're not in the U.S. and Canada, I do want to mention you definitely want to contact MecSoft if you're looking to pick up this or other MecSoft products as well. So there you go. All right, and Barbara, I think you have some things you want to mention as well.
Yes, I want to remind everybody to visit the Novedge blog for the great stories and the beautiful images of the people working on the edge of creativity and technology. And also put us on your wall by liking the Novedge Facebook page. How easy is that to get all the information on our promos and future webinars? Speaking of which, next week on the Novedge webinar, we'll have from TDM Solutions, Pedro Loureiro, who will create up to 5 jewelry design samples from scratch using features unique to both Clay U and Rhino Gold 4.0. Also, he'll showcase the all-new Rhino Emboss 1.0 beta for reliefs, engravings, and texturing. It's going to be 100% practical webinar, so do not miss it. Also, the webinars is free, and go sign up immediately at www.novedge.com/webinar/104. Last but not least, today's webinar has been recorded, and so if you want to rewatch it, or if you want to if you missed it and want to catch up with it, you can find it on our Novedge webinar series channel on Vimeo and YouTube. So it was great to watch the relay between Uday and Scott today. Great job, guys.
Cool.
Speaking of
Awesome.
Olympics.
But yeah, so yeah, thank you everybody. MecSoft team, Scott, Anita, Uday, do you guys have any last words, some parting words for our attendees out there?
Well, thank you for joining the webinar, and I look forward to hearing from you also.
Yeah, we enjoyed it.
Cool.
Thank you.
All right. Thank you. In that case, have a good one. Ciao.
Bye-bye.
Bye.